We're back with Solutions 101 Part 2, and this is concerning molarity and the applications of molarity. Before we get into definitions of molarity and applications of it, I do want to talk about solubility just a little bit more. This is a little bit of carryover from Part 1. But I want to talk just really quickly about factors that affect solubility. So these are things that can increase or decrease the solubility of a given substance. And the first one that we want to look at is temperature. And that's just, of course, the measure of kinetic energy of the solvent molecules. So for a general rule of thumb is that for solid solutes, as temperature goes up, solubility also goes up. So as temperature rises, solubility also rises, and that's just to increase kinetic energy of the solvent molecules, and they tend to grab onto the solute molecules with a little bit more efficiency that way. And then for gas solutes, for instance, carbon dioxide being dissolved in water to make soda water, as temperature goes up, solubility goes down. And that's just because as we increase the temperature, the gas molecules that are dissolved in the solution tend to move and vibrate a little bit more, and so they're able to escape the solution more easily. So temperature is one factor that will affect solubility. And we can also look at the pH of a solution, which is the concentration of hydrogen. And so we have temperature, pH, what's our other one? Oh yeah, pressure. And so we will get back to these at a later time when we talk about pH after we've done some equilibrium, and then pressure when we get to gases. So those are a couple of other factors that can affect solubility. Right now, the one that you really want to remember is that temperature increases solubility of solid solutes, and it decreases the solubility of gas solutes. Okay, so that was just kind of like a little carryover from Part 1. And Part 2, what we're looking at here is the ratio of solute to solvent particles in a solution. And the ratio of solute to solvent particles in a solution is described in the word concentration. So in everyday life, we think of concentration as how hard we're thinking. In chemistry and in food sciences, concentration is about how much solute there is per solvent. So you may have heard of like orange juice from concentrate. That just means that it's taken from a really high concentration where there's a lot of stuff dissolved to a really low concentration where there's less stuff dissolved. Okay, so let's say, for example, we have two solutions, and those are supposed to be relatively the same size. And in this solution, we have sodium chloride dissolved, and we've got 3 moles of sodium chloride. That's indicated with 3 sodiums and 3 chlorines. So that's in this solution. And then over here, we have five. And you guys hopefully get the idea that there's 5 moles here. And so if these are the same volume, and this one has less moles and this one has more moles, then we would say that this has a higher concentration. And this one has a lower concentration. And I always think of a higher concentration versus lower concentration with the analogy of Kool-Aid. You've all probably had Kool-Aid that didn't have enough sugar or enough flavoring in it. It tastes really bad. That's a low concentration. And substances like Kool-Aid with a lot of sugar and a lot of flavoring, that's high concentration. Okay, so how we express concentration. Oh, my pen died. We express concentration in units called molarity. And there are actually a lot of different ways to express concentration. We're going to focus on molarity in this class, but there are other ways like molality and parts per million, parts per billion, percent by volume, percent by mass. There's lots of different ways for you to express concentration. We're going to focus on molarity. So to find molarity, which is indicated with a capital M, if you want to find molarity, you take the moles of the solute and divide by the liters of solution. So we could say molarity equals moles per liter. And that's just a really basic expression for molarity. You find the moles of the solute and divide by the liters of solution, and that gives you your molarity. Excuse me. We can do a little bit of algebra with this. So let's say we're going to box that guy in, actually. We can do a little bit of algebra with this, and if we want to find moles of solute, we can multiply both sides by liters, and what we end up with is molarity times liters gives us the moles of solute. So those are two important equations that we're going to use, and I can do a couple of example problems. I'll just post another video after this. I'll call it part 3. It won't be listed on your agenda, but you should probably write down the examples. And our last equation is going to be about dilution. And what you want to remember is that when we dilute a substance, the moles of solute remain constant. So this is kind of a separate idea here. When we dilute a substance like a solution, that the amount of solute doesn't change. And so we can say, if we use this, the moles of solute, we could say that the initial molarity times the initial liters that comes from before the dilution is equal to the second molarity times the second liters. So that would be after the dilution. So those are 3 equations that you're going to want to have in your head. Molarity equals moles per liter, moles equals molarity times liters, and M1 times L1 equals M2 times L2, where this represents before a dilution and this is after a dilution. And we'll practice more of those as we go. Look for part 3 here. I'm going to do an example problem for each one of these types of formulas. And that's it. Thank you.